But welcome. I see a lot of familiar names in the list of attendees and a lot of names that I don't recognize. So we figured we would start with just kind of a very quick overview of AUD, Automated Utility Design, and let you know a little bit about SBS and AUD, and then we would go into the AUD to ArcGIS Utility Network Integration. So with that, presenters today will be myself, Jim Lucas. I'm an executive consultant, which basically means I plug in wherever I need to, whether that's project level or demos or development. I just kind of bounce where I need to go. And Sergey Sokolov, who is our genius with solutions and architectures, he has been really running with the Esri utility network integration and has put together some really phenomenal stuff for you to see today. Our background is more spatial business systems is more of as a process-oriented efficiency kind of organization. Somewhere around late 2016, we actually inherited a portfolio of products from Autodesk. So those included Autodesk Utility Design, which became Automated Utility Design, as well as our Substation Design Suite, SDS. And since 2016, SBS has owned those products, expanded those products, implemented those products, licensed those products. We own them going forward. So we have this really neat background of being all about process and efficiency, but now having a set of tools where we can merge those two. And we really, as you see this, you'll see that the efficiency of our design solutions comes from the whole of our company, right? It's not just the design tool, of which we have a really kick-butt design tool, but it's this overall process efficiency in addition to the efficiency that you get with the design tool. Currently based in Littleton, Colorado, and we also have an outpost in Melbourne, Australia. We're pretty active over in the Australian community, and it's kind of cool because they do a lot of advanced things like LiDAR and 3D and some of those things that the United States is heading towards. So it gives us kind of a preview of what the utility industry could become. Automated Utility Design, AUD, is a plug-in to AutoCAD, the Map 3D suite of products. So it's you get all of the functionality of AutoCAD, all the functionality of Map 3D, and then you get all of the functionality that we add into the mix with Automated Utility Design. It is 3D, even though you draw in 2D, it attempts to auto-generate your 3D models and behind the scenes for you. And it's also standards-based, so we can do validations on your design process, as well as generating analysis and bill of materials and job estimating. Now, what you'll see today is actually our integration through the Utility Data Hub GIS, and that's where we pull data in from the GIS and put data back to the GIS. We also have Utility Data Hub for EAM, which pulls data in from a work management system and puts it back to a work management system. We also have Utility Data Hub for analysis, which, as you guessed it, pulls data in from an analysis system and pushes data back to an analysis system. So all of those things are available inside of Utility Data Hub. Basically, if you're going to move information into or out of AUD, it's going to go through Utility Data Hub. This is a sample workflow just to give you some context for what you're going to see today from, excuse me, from an EAM system like SAP, Asset Suites, Storms Logica, WMIS, any of these types of systems. We can pull in compatible unit information, material information, work order information. If you have any kind of mobile information, that can come in. And if you have any kind of reference GIS layers, that can come in as well. So the idea is that the user can sit in AUD and have all this information brought into them, right? Whether it's work order information or GIS information, or any of the 300 something formats that CAD reads natively, you can pull that all into AUD and have it available to the user right there when they need it. They do their design, and at the end of the design is the go back stage, right? We sit in AUD, we pull all this information in, we actually do our design, At the end, we can send back work order status, we can send back compatible units, we can generate construction packages for mobile apps, or we can export out to GIS. So it's a full round trip that we implement with Utility Data Hub, even though you're in AUD, and we try and centralize everything for you so that you can not leave that tool, which in itself is more efficient. But we also put everything back so that you don't have to worry about losing consistency, and you can enable more BIM type workflows, full data from start to finish. Important part about Utility Data Hub is that we've implemented against so many different systems, and EAM we've already mentioned, like the SAPs and Maximos and all those of the world, but in GIS we also can do Small World or Esri Geo Network or Esri Utility Network or Oracle Spatial. We're very agnostic there, but the flexibility of the Utility Data Hub is such that as we've implemented on these, we've gone ahead and put them into a core framework. So 99% of what we do with these external systems is configuration, which makes the Utility Data Hub really flexible, but also really maintainable going forward. If you switch between Esri Geo Network to Esri Utility Network, it's just a reconfiguration of our Utility Data Hub to point to the new one, and your users don't really see that much of a difference in AUD to AUD. It's still a pole, it's just being pulled from and written to Utility Network instead of pulled from and written to Geo Network. So we insulate you from these through the Data Hub, and we make it very configurable and flexible. And then last slide, I believe, just so that you can see how the structure of Arc Pro works. And Sergey can talk a little bit more about this whenever we get there, but essentially one of the advantages of having the Arc Pro is that it's all web-based, right? So even the Esri client machines use the REST services, even though they're a desktop-based solution in certain parts of their solution, they're still going through REST services and communicating through web protocols in order to talk back to the main Pro database. And we're able to do those same kinds of things and leverage many of those same services that core ArcGIS Pro are using to make AUD that much smarter or that much more efficient. So you'll see a lot more of that when Sergey's going through. Let me go through and show you very briefly about what AUD looks like. Here I happen to have electric and gas loaded. And just to give you some context in AUD, this is full AutoCAD. All of your AutoCAD functionality is there. You still have your same, import CAD drawing that you've always had. So, all your functionality for importing and working with the LiDARs and GPS coordinates and CAD functions are all still available. But when you get to the point where you're ready to do intelligent design, intelligent modeling, then you move into AUD and our electric and gas and water and comms and whatever data model tools that you want to use. The same basic layout exists for everything. There's a set of tools, all configurable. There's a set of drop downs that represent different commands, again, all configurable. And there's a set of defaults. Again, all configurable. These defaults allow you to choose kind of the base models that you start with. And you'll notice as I switch back and forth between these single phase and three phase, these all change. These are all configurable as well, even down to the point of what's displayed in the profile. So default profile only has light and transformer, but as soon as we switch to three phaser, now it's a transformer, fuse, and riser. So everything you're seeing here, the names, the drop downs, the way that this is structured, the defaults, it's all configuration for us. But you basically come in and tell AUD that these are the things I want you to start with. A 40 class 4 pole, I can always bump that up to 45.1. A certain type of conductor, a certain type of framing. When I draw, I want you to start with those things. And then we come up and we say draw. And from this point on, it becomes kind of like a CAD placement. You can see there's arcs and offsets and path options, and you can do lots of different things in here just as a CAD user. But then the intelligence of AUD kicks in. You see this validating and resolving bar that comes along, and there's a bunch of stuff that happens behind the scenes. So as soon as I placed and I told AUD that, hey, I want to draw an overhead line, and I want you to start with this kind of primary, AUD was smart enough to go ahead and put the poles on the end to calculate out the guying, the sag, the pole moment analysis. So all of your analysis happens while you're doing that. So you can see there's overhead results for that. There's guying calculations for that. And then if you were doing any kind of service work, there's voltage drop and flicker calculations. So those take place automatically. All of your features are placed, and those features are intelligent. They have attribution in them. Your parent-child relationships are maintained, so you can have three-phase wires, single-phase wires, all that kind of stuff. Your materials are generated. So on placement, those models that we have up there, they're not only just, for show, they actually understand that this is a particular kind of pole, and this is the material or materials that go with it. And then any kind of validation that would result. For instance, if I happen to have a transformer out in space, you would see that this transformer is not connected to a conductor and a minimum of some type of primary cable. So these design standards, these design validations, also configurable, are also taken into account during placement. So very brief overview of AUD to put some context in there, just to show you that it is a design tool. It's meant to be design. It's meant to be very efficient for the user, where you draw in CAD. We consider it to be a modeling tool, because as I switch my model around, it will recalculate, it will revalidate, it will redo all these analysis and feature properties and material editors and validation results. So you can see that you can shift it around, and AUD adapts with you as you adapt your design. Switch over here very briefly just to show you kind of what's going on behind the scenes. You can see the 3D models are kind of drawn for you. It's showing the sag that's happening. It's showing the poles, the pole framing, the guying calculations. Users use that in different ways. You can just stay completely in 2D, or you can jump to 3D to kind of give yourself another way to check your design. That is the overview of AUD and the overview of SBS. Feel free, I think there's a way to type in questions into the command console there. So if you have any questions, go ahead and type them. And then otherwise, I will turn them over to you, Mr. Sergey.
All right, thank you, Jim. I appreciate it. It's a great overview. Let me start sharing. And I will start with briefly letting you know what kind of configuration I have for this demo. As in the next half an hour, we'll be really focusing on the workflow side and user experience. So I'll walk you through the end-to-end workflow, and for a typical utility, and showcasing different steps integrating AUD with Esri, ArcGIS, Enterprise, and Utility Network Extension. So on this environment, we have set up Esri ArcGIS Enterprise with the ArcGIS portal and ArcGIS server and Utility Network Extension, and geodatabase running in Oracle 12c and with the utility network sample dataset from Naperville that was provided by Esri. And as for those who've been working with Esri before, there's a concept of Esri geometrical network, where the features are properly placed, but there may not be enough capabilities in the tools coming from Esri to manage network connectivity and topologies. Esri new utility network actually provides all the tools and the models for utilities to create and manage not only just assets location, but also relationships between those assets, like a containment, attachment, and connectivity associations. And as Jim explained, it's a very simple diagram. We have AUD as a plugin to AutoCAD Map 3D, and it's connected through feature services to ArcGIS Enterprise. And we also have ArcGIS Pro 2.5 running and showing the same data. So that's the setup. If you have any questions or need clarifications, please raise your hand or type in your question in the chat window. We have a team of experts monitoring the chat and will be able to help you. Or, of course, feel free to interrupt me and we can explore the workflow or technical details to whatever level is required. As I mentioned, we'll be focusing on the workflow aspects. So I'll be playing, in this case, a role of two roles. I will be playing a role of mapper and designer, and I'll be using two different tools. Mapper will use ArcGIS Pro. That's what you see on your screen. And when I switch to my role as a designer, I will be using AUD. We'll start with GIS. In this case, you observe the ArcGIS Pro connected to utility network services. If I zoom in, pan, you'll see the electric distribution network. What we can look at, there are multiple ways of configuring utility network. There is a different level of details, and the good news, and so really shows the flexibility of the utility network model. It allows you to either kind of model in a way you have been doing it in geometric network, or add new additional capabilities of modeling internals of those devices. So to the level of details you need to manage electrical connectivity in your electrical topology in utility. So in this case, I've just navigated to pad mount transform, and you see if I zoom in, you observe that it's actually an assembly, and I can navigate, look at containment, select this assembly, and it shows me there is a pad mount transformer 3-phase, and there are a couple of load elbow breakers and the connection point. And if I explore connectivity of that transformer, you'll see that it's on the high end pad mount transformer connected to 2 load breakers, and on the low end it's connected to attachment and to the service. So it shows you that utility network operates at the level of ports and allow you to very granular modeling on electric topology. Another interesting part, and so let's move on the area of our design. We will be working on providing a service to this new development. So there a work order was created, and in the work management system, and the scope of this work to use this pole as a takeoff and run overhead along the lake, and then switch to underground and deliver 2 services to new construction site. So this work order was created, and designer has been assigned. So now I'm switching to AUD. I'm now a designer, and I received notification from my work management system. The work order has been assigned, and I need to do that work in a work order area. As soon as I start AUD, you can see I actually, as a designer, can navigate, zoom in, and view the GIS utility network data. And that is really a live connection. I'm not importing, exporting. Because of architecture, great architecture, implementing feature services introduced by Esri, we can in AUD leverage all those capabilities and connect AUD directly to those services. So the data is streamed directly from Esri ArcGIS server, and that's utility network data. So I can navigate, pan, zoom, and observe and explore features. For me, in order to make a decision on where and how to connect services, I also need to probably navigate and understand how the circuit is configured. And the best way to do it is to do a trace and find a breaker. Perhaps in the previous life, you would have to go to GIS and run the trace and figure out where the breaker is in AUD implementation with Utility Data Hub for utility network. We can actually run the trace, find the breaker from within my design session. So I'm just clicking on any feature, and you can see it traced and actually highlighted the trace, and allows me to zoom in and show where my breaker is. And I just want to stress it one more time. I'm not necessarily bringing in any features from GIS. We just call the function feature servers in utility network, and we told the execute a trace and highlight results in AUD. So that gives me a great way of looking at and leveraging capabilities of GIS within my design. So that's a really core to fundamental concept to how we see designers using the tools. They don't have to leave AUD. They can stay within the design and leverage all the capabilities available in enterprise, like GIS, running trace, get the work order details. All is available on my fingertips right here within a session. Jim also said we can leverage all AutoCAD capabilities in bringing in data like construction, like subdivision drawings or additional plan drawings from a city. So that's AutoCAD capability. Or we can bring in additional information from external services, like I'm getting Bing imagery as an overlay. And so that just helps me to consolidate all relevant data that I need in design and help me to make an educated decision right here in my session. In the same fashion, I could add layers of data collected in a field from a variety of mobile devices and applications from Esri or other vendors. That will probably indicate additional design constraints. So if I visited as a designer, have done some field research, I could have captured, for example, accurate location of the structures and like a pole, the takeoff pole, and I can use that information in my design. And we'll see how this can be done. So I'm ready to start design and collected all the data. I know they're based on the task or work order what I need to do. And the first step for me is to really do the transformation of the features from GIS into models of AUD. Because again, we operate and engineered models in the 3D, and we can leverage definitions of those assets from GIS to create those models. Utility Data Hub provides you just one single button option. It allows you to select a few takeoff features, or you can click this and select a few features on the screen, or just individual feature. And at this moment, when I click OK, system will connect to ArcGIS Enterprise, query those selected features, and convert them. So let's do this. So now system uses feature services to get the selected subset of GIS features and transforms them into models that have been configured in AUD. And now I have those models available for me created from GIS asset attributes as a models in AUD available for my design. So let's explore what's happened, and let's look at our pad mount transformer. And you remember there was a number of features part of that transformer, but for design, we operate with a pad mount transformer, which is represented as this block. But in order for us to maintain integrity of data, we also preserved all the relevant information stored in GIS, available in GIS, and have it for analysis or inspection in the design tool. So as you can see, it's a pad mount transformer. Transformer is on a pad. That means the containment relationship of utility network was maintained, and when we transformed features, AUD also understand that containment relationship. So pad contains transformer, and transformer is on the pad. We also looked at connectivity details, right? So if I look at connected, you can see that transformer is still connected on the high end to the incoming three-phase, again outgoing three-phase, and one service serving this major shopping center. In attribute level, I can see that there is a global ID of that transformer preserved by transformation, so we can reference any changes done to those features in GIS in AUD using the same global identifier that was defined and created by ArcGIS. The interesting part that now using the attributes from GIS, all the available attributes, this asset has been mapped to the model that's configured in AUD, and it can participate now, and we can use it as the model for our designs. And the status is existing, that these are a number of statuses that AUD uses to control how features are, in what state features are. So the features coming from GIS are existing. If we modify those features in GIS, we can set status existing, modified. For example, if you found something in the field that was not there in GIS, you can put those features and sets existing rearrangement. That's not a part of design, but really a new feature that was found or removal. There is a nice way of communicating with the system of records like EIM or GIS, identifying that certain assets are labeled by design as a removal, and that will take its own process in assets lifecycle. All right, so now we have all the basics done, and actually it just took me longer to explain and clarify all the details and just then do my design. And let us focus on design this time. Now, this is my pole, that this symbol represents location of the pole, but looks what's happening. Once we imported this pole in AUD, you can see that's the same global ID. This pole came from GIS, and that's electric medium voltage pole from utility network. But location has been shifted to exact location of that structure in the field. And the reason and how we have done it, it's either this information can be available in GIS, or information was collected during your field visit. And because of the structure ID can be used as a key, Utility Data Hub can merge your data collected in a field with records from GIS and place structures, in this case pole, on very accurately on the exact location where it's in a field. Because that's what we need for design in AUD. And you can see actually shadow from that structure coming, so you can observe that's the real light location of that pole. Utility Data Hub also allows you to do actually look at data if it's available in Google Maps, so I can observe and see, yeah, that's the structure that our takeoff pole. So we'll walk with this structure as is now. Let's start design. And we will use AUD electric tool, and Jim explained all the basic settings for our work order, electric overhead. So I will start with drawing my pole overhead three-phase, and as I start digitizing, you can see system takes care of placing features and adding other features. Let me turn off the GIS layer for now, so you don't see this flashing images. So I'm turning off GIS layers. So system placed pole at the end, and I'll continue here for underground. To go underground, I will need to place a fuse on the pole. As I mouse over location, you can see system tells me that this fuse will be attached to a pole and connected to a conductor. And that is really, really important, because while you digitize, system behind the scene actually manages those relationships. That's important for GIS. So let's see how I'm placing riser now. You see, when I mouse over, it tells me the riser will be connected to a conductor and attached to a pole. But I'll just use a very simple drafting showing my intent of my design. And system actually does the heavy lifting of updating materials list, and I'll keep it open so you'll see how materials added and doing all engineering analysis. Now I have riser, and I go to underground, and I'll draw my primary line connected to pole riser, go around the lake here, enter. And as you see, AUD also updated, added material catalog, added sweepers, calculated pulling tension. So I'll place pad mount transformer connected, and from by doing this, I'll continue with a couple of services. So I'll continue drawing service line with a duct. I connect to pad mount transformer here and serving this pool in this area. And system adds underground duct, conductors in the duct and service point. And I'll continue in this direction just to provide the service to this building here. Of course, you can use all the rich capabilities of AutoCAD to do precise offsets and placement of features. Now we have design as planned, so we overhead providing services. AUD has a set of rules that always run behind the scene, and run validation against construction standards that's been configured. So I can check my validation results, and I see some challenges. So the best way to review, I can switch to a 3D view, and right there you can see some challenges. In this case, the wire is going to the ground on that pole. So let's check why this happened and what is the reason. Now, the explanation is simple, is because in GIS, in this case, in this model, there was no details about the cross arm on the structure and attachment height, which we need in order to complete our design. And from my field visit or other records, I know that this type of a cross arm, I can assign it, and then the system tells me that the pole, I need to adjust, update pole height and attachment heights. So now you can see the system really automatically attached, properly placed cross arm, and now you can see the secondary circuit coming out, and that's the circuit that was there in GIS. And also system checks engineering standard that tells me, oh, you know what, in order to support those circuits, we need to upgrade pole class to 50. So I'll do that, and you can see that it changes the size of the pole structure. No more warnings. It means everything is in accordance with engineering standards. You can actually explore all the connections in underground, how it's done in a very detailed in AUD. But from engineering standards, everything is ready, and we've done our design. So the next step for me would be to go to Utility Data Hub and submit materials to cost estimating to EAM system like Maximo or SAP, and create construction sheets with layouts in AutoCAD, which is very, very simple, straightforward. So I can create construction sheets as I need to. Once the design is approved, the construction sheet is created and ready for construction or on other event in your workflow, designer is supposed to update GIS, publish data to GIS. So that's where we have our utility data hub will helps easily to update GIS. And in this case, I press button, export to utility network, and that's it. Data is published for processing to GIS system. Now I will do a little bit of technical, 2 minutes of technical discussion here. So I'll explain how we communicate with utility network. So in the utility network, when we send data back, we do not really update utility network GIS features directly. We stage transactions, all the changes done in the design in AUD in costed feature layer, which is actually contains relevant information for and can view the details of what changes done in design. And once this design is ready for processing in GIS, the mapper will be able to connect, view those changes done in design and process in ArcGIS Pro. And that's where we are going to do. I'm switching my hat as I'm going to play a role of mapper now. Back to my, as a mapper, I'm opening ArcGIS Pro, and I'm navigating. And as you see immediately, when I zoom out or system refreshes, and it shows me that there is my new design in a pending state. So as a mapper, I also receive notification to process this design. And SBS, we provide Utility Playback Manager, which is part of Utility Data Hub GIS. So if I refresh, I can see this is drawing one. That's what the design we worked on. That's exactly a few minutes ago. It was posted. So for me, I need to, as a mapper, I need to process this. So a utility playback manager really gives you great tools to review what was implemented, what was done in design. So if I click on the pad, there is a new feature with the proposed values. If we modified existing feature like in the GIS, then there will be modified transaction, and we'll see existing value and modified value of that feature. And I can explore all the transactions or changes done in design individually, or I can select, of course, zoom in and draw preview. This gives me overview of what changes done in the design session. And if as a mapper, I'm comfortable with all changes proposed in the design, the Utility Data Hub gives you very simple one-button solution: execute. So play all those transactions. And what's happening now, the system reads the changes stored in the hosted feature layer for that design, and actually creates all the features in utility network. And it actually created features in a version of utility network. But I just want to stress the version only created at this moment. So there is no need to create versions and keep all these versions for a long period of time. It's only done for at the final stage when the system or there is an event that telling, yes, now we need to update our GIS system. And in this case, what I can do, I can actually explore in utility network, there is a validation, so we need to run validation. And if any issues, any concerns, system will tell us if any issues. In this case, no issues. So what we can do, we can, we're ready actually, if I turn off this later, drawing is, work order is completed, and the features are in utility network. So I can validate the details. So look at the containment, select container, and you can see that's it shows that containment relationships have been preserved. So we are every features been transformed into utility network model on the fly, and they maintained attachment, connectivity, and containment relationships as was defined in AUD during the design. At this moment, mapper, and you can see there is a real transformation in our design. There was a simple block showing the location of padman transformer for construction with exact instructions and in accordance to construction standards. But in order for us to create and support a model created by utility network, in this case for this utility, with all the level of details relationships, a utility data hub allows on the fly to transform design model into utility network model while preserving all the relevant relationships. So the same happens here on the pole. We placed fuse with the fuse bank and 3 phases, and we look at the connectivity. You can see the features are connected and can be traced, and everything is up to the standards of utility network. So now mapper, I can only, what I can do my version and management, reconcile, and post data into default. So there is little extra needs to be done other than just reconcile and post. The integration implemented by SBS between design tool and mapping tool really makes this easy and transparent for users using the tools. Right, so this is, we completed the entire workflow, and I hope you have questions. I know you have quite a few questions. Let us open.
There were a couple that actually came through while you were presenting. So wanted to go through those real quick. Yes, Ryan, I'm watching the questions.
Okay.
So the first question was, can we get a copy of the communication diagram, I think, which was on the initial slides? Is it enough to go ahead and post the video, or do you actually want the slide set? That was the first question. The video would be great. Okay. So the next question was actually about the video, and it was asking whether or not you can please send us a link to the recording. Absolutely. Ryan is going to send out an email after this with a link to the recording. So you'll be able to see the slides and the communication diagrams, as well as the entire demo that Sergey just did. Next question was about the geometric network and the utility network, and is AUD compatible with both of them? Sergey, if you could go back to your AUD and go to, there you go, that looks fine, Utility Data Hub GIS. What this is showing is actually utility network electric. We also have a similar demo with utility network gas. But you'll notice in the top left corner, there's also an import ArcGIS geometric database. So we've had an integration with the geometric network for several years as well. So when we say we're agnostic on the Utility Data Hub GIS side, we really kind of are. We have the ability to pull data from utility network, pull data from geometric network. We have the ability to pull from geometric network and post to utility network. When we do our transformations on the import, we have the ability to augment data. So in general, out of the box, when AUD pulls in a pole, it doesn't just pull in the GIS information, it also augments that data with pole model data so that we know how strong the pole is and what the max moment analysis is. But we can also import from external databases like customer systems or additional engineering databases to augment your data. So that import is very powerful, very flexible, and, doesn't really care if it's utility network or geometric network, although you do get some additional benefits by having utility network and it all being web-based, and some of the integrations are a little easier.
That's correct, and but just to complement what Jim explained, we're not necessarily constrained to do it one or other. We can do both at the same time, at the same session. I can import features from utility network, import features from GIS, geometric network, and do updates for respective features or export into different database. So it's really flexible in the configuration. And if you have scenario like this, we'll be happy to work with you and explore that scenario in more detail. Jim, any other questions?
Yeah, there's a couple more in here. So the next one was explain briefly how material info from SAP or Maximo would be brought in. Behind the scenes, the Utility Data Hub, the next one over, the Utility Data Hub design, actually has the ability to read materials into AUD. So there's essentially a job that runs in the background that allows those materials to be updated periodically from your work management system. And then once that job establishes it's a SQLite database for size and speed and portability, when AUD opens, it can be configured to pull that database down, either on open or on open over design, or to check whenever you open to make sure you have the latest database. So the material stuff is mostly handled behind the scenes with Utility Data Hub, and then the client just receives that whenever it's ready to be updated. Video would be great. We'll post that, get that out to you. Slide deck would be nice to have. I'll check with our folks and see whether or not we can get those posted as well. Any plans for designer to reconcile posts rather than going through additional mapper states? This workflow that we presented is just a standard workflow that we see. It's fairly common in the industry. But it is completely flexible, just like the rest of AUD. We happen to have configured it where the designer hands it off to a GIS technician, and we've even configured it where we actually click a button that sends it off to a GIS technician. That's more just to demonstrate the capabilities and show you some of the functions in AUD. Your workflow, we work with you during your project to figure out the best workflow for you. And if that workflow happens to be that you hold the design out in CAD and never even post it till the very end after as-builts, that's entirely possible. If you have a workflow where you post it in the middle before construction and then post as-builts after construction, that's possible. If you want a workflow where the designer posts it or the GIS technician posts it, that's also possible. These are just, think of them as building blocks. These are functions that are available, some capabilities that AUD and UDH enable, and the order that you put them in is what we work out with you that works best for your process. The next one. How does it manage underground duct and cross-section associations? So very good question, and it digs into a little bit more detail than we can probably get into today. The feature itself, if you go to your feature info on that survey, maintains relationships. So you can see that there is a segment that you can think of kind of as the trench in the ground, and then that segment can contain ducts or conductors for direct buried, or multiple ducts or duct banks that have ducts. That trench can contain every combination you can think of that you would normally put in a hole in the ground, right? Whenever we do our underground, in many cases, not all, but in many cases, the pads or the vaults or the manholes will have ports. And we actually can route a particular duct to a particular port, and that allows us to even put those ducts in a particular place in a trench. So we can track down as deep as you would like to track down into what position the duct is in the trench, what position that duct enters the vault, what position the duct leaves the vault, what conductor that duct has. And then we can provide, there's several tools for providing cross sections and manhole flyout diagrams and trench configurations, all with what we call details. So those details are intelligent and allow you to interact with that stuff. And then when you interact with it, the detail automatically updates. So that in particular, if you want to dig into that, I'd recommend just reaching out and letting us set up a separate session with you, because there's a ton of detail that we can go into with our underground management and cross sections and ports and vaults. It can be pretty complicated. Let's see. Got that one. Video, slide deck, reconcile. Can you explain how AUD deals with elevation data? Sure. AUD, because it's in map 3D and map is civil surface aware. If you are using any kind of CAD recognized civil surface, elevation data kind of surface, when you place an AUD, it inherits from that surface. So a pole would be up higher or lower. A vault would place subsurface. It would place under the ground. The conductors would run, point to point, and then there's all kind of transitions that you can do to make that cable curve or change depending on whether there's, surface stuff running under it. We also have the ability to apply things to a surface after the fact. So even if Sergey had drawn the drawing just on flat ground and we received the elevation later, we can then do an AUD elevation set and apply the design to that surface. So because we're in CAD that's civil surface aware, we can take that elevation into account whenever we do design. And all of our analysis takes that into account too. If you do sag on elevated poles, or you do cable pulling tensions on different elevation vaults or whatnot, all of that is taken into account with the analysis. Engineering analysis is fully developed. So our engineering analysis tools, we always tell folks that they are kind of like the 80% tools, right? The engineering analysis tools help you do standardized, efficient, somewhat analyzed type designs, right? I would not put our calculations on par with like a SPIDA-Calc's finite element analysis or OCalc's detailed analysis. In general, what we do with our calculations is for material choice and for the bulk of the situations that designers face. But if you're in downtown, some city, and you have 4 double circuit cross arm turn poles, buck arm turn poles, you're going to want to run that through an analysis tool. And there are multiple workflows that AUD can enable with Utility Data Hub analysis package, where we could send data out. You could draft it in AUD and send it out to OCalc or send it out to SPIDA-Calc and have them return back whether or not this will work. But our analysis is built in. It's really good at like a cable pulling and a voltage drop flicker. But when you start getting in some of the structural calculations, I would say that you definitely want to rely on something like a SPIDA or an OCalc, which uses a newer finite element analysis type approach to it. Now that can be, I will say that, but we have a lot of workflows where the standards department has access to SPIDA and OCalc, and they kind of pre-calculate your standards so that if you do X, then this is Y. And then we bake those standards into the product, right? That can be your design validations and your design standards. So you don't have to necessarily have a workflow where you're going from AUD direct into analysis. You could have your analysis just in your standards department and then make those standard part of AUD. But in general, in utilities, we do see some sort of analysis package as being part of the design workflow. It's just where you implement it. I know we're a little bit over time, but I think the last question I had was, are things like the conduit and analysis and things like that maintained in the utility network? And I think you'd have to answer that, Sergey. Are positions and ducts and duct bank relationships and all that able to be maintained in utility network?
I don't think this is out of the box in the model. We certainly can configure it and manage all the relevant information, but there is conduit management tools are not in out of the box model. But that again, it's may absolutely change in the future releases. Esri is working always to add new capabilities to utility network, and this may change with releases of utility network in the future.
That is definitely one that would be a candidate for kind of an engineering database. We have several clients who store the route of the facilities in the GIS, but then tie that route to an engineering database that stores the duct configuration and the number of things that are in it and what position they're in. That is entirely possible with AUD. You could have your routing stored inside of the GIS, and when we pull the routing in, we'll augment that data with data from your engineering database and reconstitute or recombine those two things into something that means something for AUD. So we have folks that do that kind of engineering database extension to their GIS as well. These are all really good questions, Joe. Do you have other things you want us to go through? Want to be respectful of your time and not keep you if you need to go. But always happy to answer questions about AUD. Okay, I don't see any more questions coming in, so I'd like to say thank you for joining us near your lunch hour and spending some time going over AUD and utility network. And if you have any questions, please feel free to reach out to us. We appreciate your time. Everyone have a wonderful day and stay safe out there.